Good afternoon to all of you. Thanks to the organizing committee for arranging and inviting me, and thanks to you all for vessel sharing since morning. My topic is little mismatch with the session, because basically this is a paper of finishing that comes under chemical processing. It's not a nano production. I am basically as a professor in India, and my topic is 10. And all are popular in industry depending on the requirement by the industry, and the cost. Cost is also a factor, and is definitely is a costly one. So first I have made for comparison, all should have similar solid content. So I have taken nano, I have taken 10, 20, 30 grams per liter, but these three have different solid content. So I have equivalent solid content I have calculated. This is the formula for base, and these are the actual content in three cases. This is for 3 nano, 3 micro, 3 micro, this is 3 macro. These are the symbolic 10 gram. This is equivalent to this. Na10 equivalent to Mi1 10 and Ma10, like that. And these are the actual solid contents. These are calculated the exact solid content in these three. So first I have tried to study these hydrophilic properties, how the finish has affect the hydrophilicity of the fabric. And these are applied on cotton material. These are applied on cotton material by these padding techniques. Is not mentioned here. Hydrophilic property I have studied 2 ways. One is drop column test. A drop was falling on the fabric and it just noted the time. It can be observed that these nano and untreated I have mentioned concentration 0. If we are next, concentration 0 means untreated. And these nano and they are very similar, 1.5 and 3 seconds. But macro and micro, they took more than 5 minutes. So I have not counted. Here I have just noted nano. See, a 1 gram fabric folded to 5.5 and then just drop the fabric on water surface. And time taken was noted. In this case, both untreated and nano, they took only 2 seconds. But micro and macro, they took around 50 seconds. These curves are plotted here. So it can be concluded that nano and these untreated, they are very similar surface characteristics as far as hydrophilicity is concerned. But macro and micro largely different. They become quite hydrophobic after finishing. And this, you can see this is macro and this is micro. So this is macro and this is micro. In both cases, with around 10 grams per liter, the hydrophilicity time required was very high. Then it does not change much with concentration. It does not much change with concentration. So with very little amount of micro and macro, the fabric become hydrophobic. Then crease recovery property. It was found that crease recovery that was measured in terms of crease recovery angle. Crease recovery angle increased by all. This was improved. Crease recovery property was improved by all subunits. Maximum was with macro and minimum was with nano. And crease recovery angle, this change in concentration directly. Directly proportional. At lower concentration, shear was much higher for macro and micro. At higher concentration, they are very close. And the linear relation was linear for micro and macro, but for macro, this one, the shape is like this. So with concentration, the correlation is not good. So that means it has reached to optimum level at very low concentration. This afterwards there is not much improvement in the crease recovery property. So From this we can consider that there is higher surface deposition in terms of macro, so it has upward there is not much change in the crease recovery. Then stiffness or bending length. This was the flexibility of the yarn and fabric increased. Untreated was the stiffest, then followed by micro, nano and micro. Where had bending length inversely proportional with concentration. Means with increase in concentration, bending length decreases. And linear correlation very high for all both warp and air. There are few exceptions. Like for nano bar, there may be some experimental error. Otherwise, it sharply decreased with concentration. This bending length sharply decreases concentration. So we can conclude that there is surface deposition, that is smooth surface in case of macro, and micro is a combined effect and balance to render lower bending length. Nano penetrate much, inner softness, so there is no surface modification, so bending length has not changed much with nano. Then drag coefficient was lowest for micro, followed by nano and macro. Micro softener made the fabric most flexible. Micro softener made the most flexible. Here also, these are very similar to drag coefficient and bending length. They have similar depth. They decrease inversely. They are inversely proportional with concentration. And for micro correlation is very high. Micro rate of decrease highest. Micro rate of decrease is highest. This dropping rate is highest, and the nano rate lower, below 20. And here, in case of nano, there is not much change in drag coefficient after 20 grams per liter. So the trend is so. This trend of drag coefficient is very similar to that in case of bending length. Then tearing strain increases with concentration, linearly proportional with concentration, increases highest in case of micro, followed by macro and nano. R square, there is correlation was quite high in all three cases. Then in case of weft, there was little bit correlation was little bit lower, and because there is rapid increase in initial state and there is a drop, so that's why correlation was not high. So fiber application is predominant in case of micro, facilitating grouping of yarn and subsequent increase in tearing strength. Then the same in case of nano. So in case of macro, they give much of fiber lubrication, but nano could not give much lubrication because it penetrated inside. So there is not much significant change in nano. Then abrasion resistance. Softener lubricate and reduce interfiber friction, hence strain loss during abrasion decreases. More softener means less loss in abrasion resistance. Abrasion. Strain loss during abrasion. Strain loss decreases in concentration, but at 20 gram, reverse strain observed in few cases. In these cases, there is reverse strain. Other cases, it was decreased. This loss of strain decreases with high concentration. So average strain loss for one word highest in case of macro and lowest for nano. Macro finish fabric, so higher strain loss indicating severe disintegration of yarn assembly than the same of micro and nano. So in some cases there are some poor correlations, very experimental error. So we have done two ANOVA test. I have given an example for this CRA. Is recovery angle. So this is example for a particular case. In case of CRA, but for bending length, tearing strength, everywhere I have calculated this ANOVA test. One example has shown. In this case, in case of CRA, it can be shown that F actual from the table that exceeds the standard. This is the standard table value with this degree of freedom. Nu1 equal to 3 and Nu1 equal to 3 and Nu2 equal to 6. With this variance, table value is only 4.6. But we have this octane 21. And in this case, this is for concentration and this is for softener, this ANOVA test, this gives actual value 7.9. This was also higher than the table. So what it comes to is that variation in concentration and softener are significant. This is a significant test we have done with rate test statistically, whether the change in property is significant with concentration and softener type. It shows that this ANOVA test with all this is only one example I have done for others also. Other properties, in every cases, the changes with type of softener as well as with concentration were significant. Then relative softness. Manually I have selected 10 judges, some students, some teacher faculties who are very sensitive, and then I asked them to rank these samples. There are 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 samples. So I asked them to rank. This is the AATC method. Method is given, AATC procedure. This is the method. So the best one, he or she ranked 1, best one, and then next best 2, and accordingly it is ranked. So this is macro, these 2 are 3 macro, these 3 are micro, and these 3 are nano. These are the ranking, and under bracket this is after loading, after washing. So this is graphical shown here. Total rank. This total rank I have plotted there. This is total rank. This was the average for 10 judges. So this is the total rank. This I have plotted here. And it can show completely you can see nano with the softest. Because ranking is less means they are good. So these 3 best followed by micro, and then macro is the least soft. And interestingly, even in concentration also, it is matching. All 3 nano is better than all 3 micros, all 3 macros better than all 3 micros. It's a very good observation was observed, and this relative ranking of sample remain unchanged even after 2 hours washing. This laundering under bracket. This under bracket, these are the laundering. So there also this ranking. So that prevailed even after washing. That means after washing, softener didn't change much. This is coefficient of concordance that we have measured how was the ranking between the observers. That we have studied by this between the observers. That coefficient of concordance were measured, and when when this ranking is poor, W is poor, 0 that is poor, and when it approaches to 1, there is a close agreement. It was found that this table has not given. So these are the 2 values. Coefficient of concordance of the ranking by the 10 observers. So before washing it was 0.67. This is closer to 1, and after washing, because this is the second time evaluated, they become more expert. So their judgment was much closer in second time. So even judges are in good agreement. So in both cases, 10 judges are nearly in close agreement, and closeness is not due to by chance. It was not by chance. Experimentally it was proved that judges were quite in close agreement, and that was not by chance. It was due to the property of the sample only. So these are the observation on the ACM, scanning electron microscope, micro softener. This is untreated. This is macro, this is micro, and this is nano. So if you can see, my macro softener deposit more on the surface. In this case, more deposition on the surface. Micro softener treated sample roughest surface, and nano softener treated very smooth surface. So what you can know, macro softener treated surface shows a phenomenon intermediate between macro and nano. Nano softener penetrate into the fiber. Here is more penetration, this is more on surface, this is in between.
To the fiber side.
This is for cotton.
Yeah, that's only for cotton.
Yes.
But if you treat it, for example, your softener treat other materials like wool or maybe.
See, it's requirement is different. Wool we don't need any very soft. Wool as such, the natural wool, we want that is love and warmth and all this. If it is filled up, it will give less warmth.
Right.
We want
so
lower structure. Cotton is, because in case of cotton, after covering a lot of oils and fats go there, so it becomes hard. It will not swell in the market. So cotton needs softener, but other general and silk itself is softener. And wool doesn't need softener. And synthetic it cannot, because it cannot penetrate.
Yeah. So also another possibility, when you wash your fabric cotton, say, after several washes, this fibrous could be separated. That means more your micro particles may also penetrate into the fiber. Have you seen that?
See, once you are purchase and using, the softener at that time is most important. After 3-4 days, you don't bother whether it becomes soft or less. But definitely by this time, some chemical will go away also.
Right.
So it
Yeah,
will go away. So it will not make soft. Initial this thing. But nano is running good in market. There are few market nano takes and other good companies. They are giving excellent figures. All good cotton fabrics.
Also, another concept just this morning, and the professor Kawako, you want to ask the professors.